Hello, this is the second video relating to the derivatives of log functions. I am following the order of things in the 6th edition of James Strong's calculus textbook. Section 7.4 is on the derivatives of logarithms. And so the previous video, 7.4a, was on the derivative of the natural logarithm. And now in this video, I want to talk about the derivatives of logarithms in general and the derivatives of exponential functions in general. We're going to tie up some loose ends in this video. Okay, first of all, the derivatives of logarithms in general. Previously on logs, we learned, earlier in my videos of this chapter, we learned that logarithm based a of x equals the natural logarithm of x divided by the natural logarithm of a, which is the base, right? So this is something we've learned in a previous video on this chapter, right? Now, we also know from the video right before this that the derivative of the natural logarithm of something is 1 over that something times the derivative of that something with regard to x. Okay, so now we've got all we need to be able to say what the derivative of a log is. So the derivative of a log based a of x is going to equal 1 over x times 1 over the natural logarithm of a, which we can write as 1 over x times the natural logarithm of a. So this follows from the material up here. So the derivative of this log is going to be the derivative of ln of natural log x over natural log a. Well, natural log a is a constant. It's just a number. And so 1 over natural log a is going to pull out. We've been doing that since we've been doing derivatives. You know, when my father was a kid, he did derivatives this way. You know, so they pull out like that, although I don't think my father ever took calculus. He of course, would have loved calculus if it wouldn't have been for this little thing called World War II. But, you know, world wars happen, and you don't get to go on and take calculus. Anyway, so 1 over natural logarithm of a. And so what is the derivative of the natural log of x? Well, it is 1 over x. So that's where the 1 over x comes from. So this comes from the fact that you pull constants out, and this comes from, you know, basically how you take a natural logarithm's derivative. And so, quoterat demonstrandum, there it is, QED. The derivative of a log based a of x is 1 over x times the natural log of that base. Ta-da! Part 1 is now completed. Part 2, the derivative of a to the x, of a power. This is a constant raised to a variable. So a to the x is an exponential function. An exponential function is where we have a constant raised to a variable. Okay, so previously in this chapter, we learned, and I don't remember whether I actually talked about this in my video of 7.2. I may have thought, let's hold off on a more appropriate time. It's the more appropriate time. But if you go back to 7.2, if you're using the edition of Strong that has this chapter on logarithms, you will find earlier that we've already realized that the derivative of an exponential function is going to equal that constant raised to a variable times the limit, as this should be h approaches 0. In fact, let me change it real quick using I Dream of Jeannie techniques. Poof, it's an h. Okay, so the limit as h approaches 0 of a to the h minus 1 over h. Okay, and this is basically the derivative, see, f prime. This is basically the derivative of 0 because h is approaching 0. Okay, and this is something that was demonstrated in 7.2. And you're like, what the heck is this? Well, now we can tell you the rest of the story. The rest of the story, basically, okay, so we can take a to the x, and remember we've said previously that you can, if you have something like a to the x, you can do e to the natural log of a to the x, and the e and the natural log cancel each other out. You could do log of e to the whatever, and it cancels each other out. Remember I talked about the string trick where you put your hand in it and blah, blah, blah. Oh, my hand's not in the string. How did that happen? Well, e and the natural log are that kind of canceling out kind of thing. Like if you take the derivative of the integral of something or the integral derivative of something. But they kind of cancel each other out. So I can take the a to the x, and I can take e to the natural log of a to the x. Okay? And that's the same, this is the same thing as a to the x. Okay, so by the rules of taking derivatives of powers, this is going to pull out of the front. just like a to the x pulled out of the front. Okay, so this pulls out of the front, and then what I'm left with is the derivative of the power. Okay, and so the derivative of the power, well, first of all, natural log of a is a constant, so it's going to pull out, just like we said on the previous slide. So we have this again reduces back to a to the x, natural log of a, and then we're only left with the derivative of x. Well, the derivative of x with regard to x is 1, because remember, when we're taking the derivative of something raised to a power, it's that's something to the power minus 1, and then you put on the front the original power. And so what happens here is the power is 1, x to the 1 power. And so when 1 is multiplied by the front, when you go n minus 1, 1 minus 1 is 0, and anything to the 0 is 1. So we're left with 1 times 1 as the derivative of, I didn't need to review that for you, did I? The derivative of x with regard to x is 1. And so 1 times that is that. So now we have it. Now we know, by the way, what that f prime of 0 actually was. It's the natural logarithm of a. We can now rest in peace knowing that the derivative of a exponential function, derivative of a constant raised to a variable, is going to be that constant to the variable times the natural log of that constant, or of the base. Okay, so the derivative of a to the x is a to the x times the natural logarithm of a. 2 woes are past, and now to the final woe of this video. So we've just seen that the derivative of a to the x is a to the x natural logarithm of a. We've just seen that. So what is the integral? The integral is basically whatever that, if we took the derivative of it, we would end up with a to the x. So what is it? Well, it's this, because remember, the derivative of a to the x is a to the x natural log of a. So when I take the derivative of a to the x, I'm going to get a to the x natural log of a. Natural log of a on the top will cancel with natural log of the a to the bottom, and we're left with a to the x. So this is the reverse of this, plus a constant. And of course, we're not allowed, a is not allowed to be 1, because the natural log of 1 is 0. And I don't know, mathematicians get kind of really upset. I don't know what's wrong with them. I'm not a real mathematician. I'm just a hack who's going by your planet. But mathematicians get really bent out of shape about having a 0 in the denominator. I really think some of them need to seek counseling, maybe, over this. But anyway, we'll leave it alone, because we're loving people. We don't want to make mathematicians upset. And so we'll say, you're just not, unless you're God. Now, if you're God, you can have a 0 in the denominator, because God can create stuff out of nothing. But, okay, the rest of us mere mortals cannot divide by 0. And so there you have it. This has been the derivatives of natural logarithm, the derivatives of logarithms in general, and the derivative of exponential functions.